In this homework problem, you're going to look at equivalent fractions in context. Use the given information to solve the application problems. So let's read the first question. Sabrina finished 2/5 of her math assignment. If there are 20 problems in her assignment, now I see the questions coming, so I'm going to get a different highlighter. What fraction represents the number of problems completed over the total number of problems in the assignment? So looking at the question, we want number completed over the total number of problems. So this is a part-whole situation, and we're told a few things, that she completed 2 out of 5, and also that there are 20 problems in her assignment. So what we need, notice I set up an equal sign, is we need an equivalent fraction that is equivalent to 2 out of every 5 problems, but we want the denominator to be 20 because that's how many actual problems are in her assignment. So comparing these two values by multiplying, we could say 5 times what number equals 20, or equivalently 20 divided by 5 is 4. So 4 is going to be our multiplier. So if we multiply the bottom number by 4 and the top number by 4, I'm just going to stretch out this fraction. 2 times 4 is 8, and 5 times 4 is 20. Okay. So she completed 8 out of 20 problems in the assignment. Let's look at the next one. Donalita ate 7 out of every 11 candies in a jar. If she ate 28 candies, now I see the question coming, what fraction represents the number of candies she ate over the total number of candies? So this problem is very similar to the last one. It's a part-whole problem. She ate 28 candies, and she ate 7 out of every 11. It's a little bit different though, so let's see how. So we know that so this is candies eaten over total number of candies. So in this situation, they tell us that she ate 28 candies and that she ate 7 out of every 11 candies. So we know we have 7 out of 11, but here the given information is that she ate 28. So that's our numerator because that's where the number of candies she ate goes. So they didn't, in the last problem, they gave us the total number of problems in the assignment, which was the whole. Here they gave us the part compared to the total number of candies. So now to find this equivalent fraction, we want a fraction equivalent to 7 out of 11 with a numerator of 28. So we can think of this as 7 times what number equals 28, or equivalently 28 divided by 7 equals 4. So our multiplier is going to be 4. We're going to multiply the top by 4 and the bottom. And we get 11 times 4 is 44. So she ate 7 out of every 11 candies, but she ate exactly 28 candies out of the total number of candies, which is 44. So this is what the question requested. So we have 28 out of 44. Let's look at the last one. A swimming team had 4 girls on the team for every 3 boys on the team. If there were 6 boys on the team, now I see the question coming, so I'm going to highlight that in green. What fraction represents the number of girls on the team over the number of boys on the team? Okay. So notice that this is a part-to-part model. It's telling us how many people were girls and how many were boys, but we're also asked for a fraction that's a part-part model. So let's write some of this information down. So we have 4 girls for every 3 boys. And notice that the question says, what fraction represents the number of girls on the team over the number of boys? So we have girls over boys in this comparison. And we want an equivalent fraction, and we're given that there were 6 boys on the team. So we'll need to find the number of girls. So notice there are 2 times the number of boys from the original ratio. So let's write this. We want to know 3 times what number equals 6. So 3 times what number gives us to 6. 6 divided by 3 is 2. So our multiplier is 2. And we also need to multiply the numerator by 2. So the actual number of girls and boys on the team, written as a fraction, is 8 girls for every 6 boys. So 8 over 6.